Okay, well this is version 1. And then, okay, so 5 said it's given that you take out 0.89 grams of the unknown solid and that you dissolve it in a beaker of 100 milliliters of water. And then there's 0.12 moles of sodium hydroxide. So you're trying to find the amount of moles in the of acid in the beaker. So you start off by writing X moles over, and then molarity is moles over liters, and then you are given, or the titration uses 84.3 milliliters, but you can't use that because it's milliliters, not liters. So 84.3 milliliters is the same as 0.0843 liters. And then, so that's going to be equal to the 0.12 moles of the sodium hydroxide. So 0.12 of NaOH over 1 milliliter. Okay, and then, so you basically just cross multiply, and then X would equal 0.010116 moles of the unknown acid. Okay. And yeah. Okay, so 5B is asking for the molarity of the unknown acid, and then so we already used 100 milliliters of water, but we don't know how many liters that is. So we know that 1 liter is 1,000 milliliters, and then we make that equal to X liters, since that's how many liters we're trying to find, over 100 milliliters, because that's the given. And then when you cross multiply, it comes out that X equals 0.1 liters. So now you can find the molarity. So you use the amount of the moles of the unknown acid that you got from part A, and then use so it's 0.01011 over the 0.1 liters that you had just found, and that equals 0.10116 moles per moles per liter. So there's the molarity.
So part C is asking to decide if the unknown acid is butyric acid or benzoic acid. So to figure that out, you want to use molar mass. So first you want to find the molar mass of both acids. So butyric acid is C4H8O2. And so to find that, you need to use your periodic table. And basically it's 4 times 12 plus 8 plus 2 times 16, and this should give you 88 grams. And then for benzoic acid, the equation is C7H6O2. So that's 7 times 12 plus 6 plus 2 times 16, and this should give you 122 grams. So then, to find out if the unknown acid, which of these two it is, in order to figure out which one the unknown acid is, you have to use molar mass. So to use molar mass to find it, you're going to use the given 0.89 grams, and you're going to divide that by what you got in B, which is what you got from A, which is 0.010116, and this should give you 88 grams. So based off of this, you should know that your answer is butyric acid. So now we have to draw the 3D structure of the whole problem. So you know that it's butyric acid. So to draw that, you start off with 4 carbons, like so. And so this carbon will be attached to 3 hydrogens. So this one will be out, this one will be under, so it's like this, and this one will be like this. And so keep adding your hydrogens. Like so. And here, this carbon will be double bonded to an oxygen, have a single bond to another oxygen, and that oxygen will be bonded to a hydrogen. Then you want to show that it's adding with the base, and so you'll draw like so. To show that this equation is weak. Okay, because it's a weak acid, you'll know that there'll be double arrows, like so. And then to draw it now with the conjugate acid and conjugate base, you're just basically going to draw the same thing, except one of your hydrogens will no longer be attached. So you'll have this hydrogen, you'll have this hydrogen, this one. Except this will still be double bonded. Oh wait,
I'm going to show you the similar reaction.
Double bonded to oxygen. Then this single bond to oxygen will no longer have that hydrogen bonded to it because it was taken to the base. Okay, so then down here, because there's no more room, we'll just show that because the base now took the hydrogen, it will have two hydrogens bonded to it. So to label it, this is your acid, this is your base, this is your conjugate acid, and this is your conjugate. Conjugate base, conjugate acid. Is that it? Is that everything? Okay, and that's
Okay, so for E, you have to write down the Ka equation for the unknown acid. And the equation is Ka equals products over reactants. So we are trying to figure out, you put the hydrogen next to the butyric acid, which is C4H7, because one hydrogen goes to the water. And for reactants, you put benzoic acid, which is C7. Anyways, I already started recording. For part F, we use the answers from part B and E to determine the H+. So what you do is you put the equation for Ka of 1.5 times 10 to the negative 5. And since we have two unknowns, you put two x's over the molarity we got for part B, so that is 0.10116, and you basically do algebra and get 0.001232.
Right here.
For part G, you just have to determine the pH of the unknown. So the pH equation is pH equals negative log, and we use this answer. So we put negative log of 0.001232, and that equals 2.91.